The minimum circuit ampacity, or MOCP, is the minimum ampacity a circuit can handle without overheating. The maximum overcurrent protection device, or MOCP, is the maximum ampacity that the overcurrent protection device can handle. The MOCP must be equal to or greater than the MCA. So, a maximum overcurrent protection device rated at 250 amps while the minimum circuit ampacity is 249 amps does make sense because 250 amps is greater than 249 amps. Now let's discuss using a higher amp rated circuit breaker as a safety disconnect when there is an overcurrent protection device at the panel without coordination. You should not use a higher amp rated circuit breaker as a safety disconnect without coordination. The purpose of a safety disconnect is to provide a means of quickly and safely disconnecting the unit from the power supply in the event of an emergency. If the safety disconnect is a higher amp rating than the overcurrent protection device at the panel, it could allow more current to flow than the overcurrent protection device is rated for, which could trip the overcurrent protection device and leave the unit without power. The assertion that the 400 amp circuit breaker is not sized for trip is incorrect. The safety disconnect should be sized to trip at the same current as the overcurrent protection device at the panel. This ensures that the overcurrent protection device will trip before the safety disconnect, providing proper coordination and protection for the unit. For example, if the panel overcurrent protection device is rated at 250 amps, the safety disconnect should also be rated at 250 amps or less. Using a 400 amp circuit breaker as a disconnect with a 250 amp overcurrent protection device upstream is a misapplication. The 400 amp breaker will not provide adequate protection for the circuit or the equipment it serves. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits and equipment from damage caused by excessive current flow. They do this by interrupting the circuit when the current exceeds a predetermined level. The selection of the correct overcurrent protection device is critical for ensuring the safety and reliability of electrical systems. Several factors must be considered when selecting an overcurrent protection device, including the ampacity of the circuit, the type of load being served, and the interrupting rating of the device. The ampacity of the circuit is the maximum amount of current that the circuit can safely carry. The overcurrent protection device must have an ampacity rating that is equal to or less than the ampacity of the circuit. The type of load being served will also affect the selection of the overcurrent protection device. For example, motor circuits require overcurrent protection devices that are specifically designed to handle the high inrush currents that occur when motors are started. The interrupting rating of the overcurrent protection device is the maximum amount of fault current that the device can safely interrupt. The interrupting rating of the overcurrent protection device must be greater than the available fault current at the point of installation. Coordination of overcurrent protection devices is also important. Coordination refers to the selection and arrangement of overcurrent protection devices in a manner that ensures that the device closest to the fault will trip first, minimizing the impact of the fault on the rest of the electrical system. In the scenario described, the 400 amp circuit breaker used as a disconnect is not coordinated with the 250 amp overcurrent protection device at the panel. This can lead to several problems. Firstly, if a fault occurs in the equipment served by the circuit, the 250 amp overcurrent protection device may not trip quickly enough to prevent damage to the equipment. Secondly, the 400 amp circuit breaker may trip unnecessarily, interrupting power to the equipment even when the fault current is below its rating. The National Electrical Code, or NEC, provides detailed requirements for the selection and installation of overcurrent protection devices. It is important to consult the NEC and other applicable standards when designing and installing electrical systems. Article 240. One of the NEC covers the protection of conductors. Conductors must be protected against overcurrent in accordance with their ampacities. Section 240. 3 covers protection of equipment. Equipment must be protected against overcurrent in accordance with its listing and labeling. Section 240. 4 covers the protection of flexible cords and fixture wires. Flexible cords and fixture wires must be protected against overcurrent in accordance with their ampacities. Article 430 of the NEC covers motors, motor circuits, and controllers. Motors and motor circuits must be protected against overcurrent in accordance with the requirements of Article 430. Article 440 of the NEC covers air conditioning and refrigerating equipment. Air conditioning and refrigerating equipment must be protected against overcurrent in accordance with the requirements of Article 440. In general, the overcurrent protection for air conditioning equipment is addressed in NEC Section 440.22. This section specifies the maximum size of the overcurrent protective device based on the equipment's nameplate ratings. NEC Section 440.12 provides rules regarding the disconnecting means. The disconnecting means must be readily accessible and capable of disconnecting all conductors of the equipment from the power supply. The ampacity of the disconnecting means must be at least 115% of the nameplate rated load current. The NEC also requires that the disconnecting means be legibly marked to indicate its purpose. Proper coordination of overcurrent protection is achieved through a selective coordination study. This study analyzes the time current characteristics, or TCC, curves of all overcurrent protective devices and the system to ensure that the downstream devices trip before the upstream devices. This minimizes the extent of the outage during a fault condition. In summary, the 400 amp circuit breaker should not be used as a disconnect without proper coordination. The disconnect should be sized appropriately to match the overcurrent protection device at the panel to ensure proper protection and coordination. Consult the NEC and a qualified electrical engineer for guidance on selecting and installing overcurrent protection devices. Consider the following points for a better understanding. Firstly, overcurrent protection is essential for electrical safety. Secondly, disconnect sizing is critical for proper coordination. Thirdly, NEC guidelines must be followed for safe installations. And fourthly, a qualified electrician should be consulted for any electrical work. Let's delve a little deeper into the role of the minimum circuit ampacity, or MOCP, and maximum overcurrent protection device, or MOCP, in ensuring the safe and efficient operation of electrical equipment, particularly in rooftop units. The MCA is a critical parameter that defines the minimum allowable ampacity of the conductors feeding the equipment. It's essentially the minimum current carrying capacity the wiring must possess to prevent overheating and potential fire hazards under normal operating conditions. This value is determined by considering the continuous load, motor starting currents, and any other factors that could contribute to the overall current draw of the equipment. The MOCP, on the other hand, specifies the maximum rating of the overcurrent protection device, such as a circuit breaker or fuse, that can be used to protect the circuit and the equipment from excessive current flow. This value is typically determined by the equipment manufacturer and is based on the MCA, the type of load, and the interrupting rating of the overcurrent protection device. A key principle to remember is that the MOCP should always be equal to or greater than the MCA. This ensures that the overcurrent protection device will trip before the conductors are overloaded, preventing damage to the wiring and the equipment. In the example provided, the MCA is 249 amps and the MOCP is 250 amps. This configuration is acceptable because the MOCP is slightly greater than the MCA, providing adequate protection for the circuit. However, it's crucial to note that the MOCP should not be significantly higher than the MCA, as this could compromise the effectiveness of the overcurrent protection. Now let's address the issue of using a 400 amp circuit breaker as a safety disconnect for the rooftop unit when the overcurrent protection device at the panel is rated at 250 amps. As mentioned earlier, this is generally not recommended due to the potential for coordination problems and inadequate protection. The primary function of a safety disconnect is to provide a readily accessible means of disconnecting the equipment from the power supply in the event of an emergency or for maintenance purposes. It should be sized and selected to ensure that it can safely interrupt the full load current of the equipment and withstand any potential fault currents. However, it should also be coordinated with the upstream overcurrent protection device to ensure that the overcurrent protection device will trip before the disconnect, minimizing the impact of a fault in the rest of the electrical system. In the case of the 400 amp circuit breaker, it's highly unlikely that it will be properly coordinated with the 250 amp overcurrent protection device at the panel. This means that if a fault occurs in the rooftop unit, the 400 amp circuit breaker may not trip quickly enough to prevent damage to the equipment or the wiring. Furthermore, the 400 amp circuit breaker may allow a higher fault current to flow than the 250 amp overcurrent protection device is rated to handle, potentially leading to a more severe fault and a greater risk of damage. The assertion that the 400 amp circuit breaker is not sized for trip is incorrect. All circuit breakers are designed to trip when the current exceeds their rated value. The fact that the circuit breaker is rated at 400 amps simply means that it will not trip until the current reaches that level. However, in the case of a 250 amp overcurrent protection device at the panel, the circuit should be protected by the 250 amp overcurrent protection device, and the 400 amp disconnect will not provide any additional protection. The ideal solution is to replace the 400 amp circuit breaker with a circuit breaker that is properly sized and coordinated with the 250 amp overcurrent protection device at the panel. This will ensure that the equipment and the wiring are adequately protected and that the overcurrent protection system functions as intended. It's also important to consult with a qualified electrical engineer or electrician to determine the appropriate size and type of disconnect for the specific application. They can perform a coordination study to ensure that all overcurrent protection devices are properly coordinated and that the electrical system is safe and reliable. In addition to the above considerations, it's also important to be aware of the requirements of the National Electrical Code, or NEC, regarding overcurrent protection and disconnect sizing. The NEC provides detailed guidelines for the selection and installation of overcurrent protection devices and disconnects, and is essential to comply with these requirements to ensure the safety and compliance of the electrical system. For example, the NEC specifies that the overcurrent protection device must be sized to protect the conductors from overload and short circuit, and it also requires that the disconnect be readily accessible and capable of disconnecting all ungrounded conductors of the circuit. The NEC also provides specific requirements for the overcurrent protection of motor circuits and air conditioning equipment, and it's important to consult these requirements when designing and installing such circuits. In summary, the use of a 400 amp circuit breaker as a safety disconnect for a rooftop unit with a 250 amp overcurrent protection device at the panel is generally not recommended due to the potential for coordination problems and inadequate protection. The ideal solution is to replace the 400 amp circuit breaker with a circuit breaker that is properly sized and coordinated with the overcurrent protection device at the panel, and to consult with a qualified electrical engineer or electrician to ensure that the electrical system is safe and compliant with the NEC. The minimum circuit ampacity, or MOCP, represents the lowest allowable current carrying capacity for conductors in the circuit, ensuring they don't overheat. The maximum overcurrent protection device, or MOCP, is the highest rated fuse or circuit breaker permitted to protect the circuit and equipment. It must be equal to or greater than the MCA. Using a significantly oversized disconnect like a 400 amp breaker with a 250 amp overcurrent protection device creates a serious safety hazard. It undermines the purpose of overcurrent protection, potentially allowing excessive current to flow during a fault, damaging equipment and increasing the risk of fire. The overcurrent protection device is intended to trip and isolate the fault quickly. A larger disconnect won't trip at the intended current level, delaying or preventing protection. Coordination of overcurrent protection devices is critical. The device closest to the fault should trip first, minimizing the impact on the rest of the system. An oversized disconnect disrupts this coordination. The National Electrical Code, or NEC, provides specific guidelines for overcurrent protection and disconnect sizing. It's essential to adhere to these standards for safe and compliant installations. A qualified electrician should always be consulted for electrical work. They can assess the specific application, determine the appropriate sizes for overcurrent protection devices and disconnects, and ensure compliance with the NEC. Remember that electrical safety is paramount. Improperly sized or uncoordinated overcurrent protection devices and disconnects can create significant hazards. If there are any doubts or concerns, always seek the advice of a qualified professional.